Hello and welcome to MAXSURF Webinar 8, Video 5 on motions prediction using Seakeeper. Now that we have our results, it's useful to be able to visualize them in a more graphical manner. So let's take a look at some of the tools that we've got available to do that. Seakeeper allows us to animate the ship motions, and it does that by converting the results from the frequency domain to the time domain. We can do that in a number of different ways. They each involve calculating the wave's surface. The first is a roll decay simulation. What we do is we heel the vessel over to a certain angle and then let it go and allow it to oscillate back to a natural position. That lets us check the natural period of the vessel and calibrate our roll damping and see if the results are acceptable. We can do that by saving the results of that roll decay simulation to a text file and post-processing them in Excel, and we'll show that shortly. We can also look at the vessel response in regular waves. That means we can select one of the particular encounter frequencies. Often we'll be interested in the one around about the resonant frequency and see the results of that. And we can also simulate an irregular wave spectrum based on the spectra that we have to see how the vessel might respond in a pseudo-random sea state. We also have some utility commands to speed up or slow down the animation. And while the animation's running, we can see the even pitch response at the bottom of the screen. So let's see how this works in practice. Over in Seakeeper, we've got our overall results, and we can see that our natural frequency for this result is around about 2 radians per second. So we'll keep that in mind for later. Now we can see our vessel, and we go to the analysis menu and choose to calculate a wave surface. The first option we're going to calculate is the roll decay simulation. So we're going to heel the vessel over to 30 degrees and then allow it to restore itself to an equilibrium position. So we calculate the sea state and the vessel, and then we go to the display menu and choose animate. And I'm going to turn on the option to save that time series. The vessel gets heeled over to 30 degrees, held there for a few seconds, and then it's allowed to roll back from side to side until it reaches a natural equilibrium position. So as it's rolling back and forth, we're calculating the heel angle at each time step, and then in a moment in Excel we'll see how we can look at that data to calculate the natural period. So I'm just let that run for about 30 seconds, which that's finished now. We stop that and let's go over to Excel and look at that data. Inside Excel, that data is saved to a text file which I can load up, and I just use the standard text parsing in Excel. And we can see that we've got some initial data, and then we've got the actual time series here. We've got the time step in the first column, and then we've got the heel angle in another column. So first of all, I'm going to select my time step data. So I'm going to select the first 30 seconds or so of that data. I'll select all of that, and then I'm going to go over to the heel column and I'm going to select the corresponding data from the heeling column. So that gives me my heel angle at each time step. Okay, so we'll get that data, and then we'll use the Excel chart wizard to create an XY chart of our data, and we can see our response over time. So we can see how the vessel's heeled over to minus 30 degrees, then it's allowed to roll back and forth to an equilibrium position. And so by looking at that data, we can measure the time distance from crest to crest and find out the natural period of our vessel, and use that to adjust our damping up and down to get a desired natural frequency response. And so we can calibrate our damping in that way. Back to Seakeeper, the next thing we're going to do is calculate a wave surface for a regular wave frequency. And remember that our natural period, our maximum oscillation, was around about 2 radians per second, so I'm going to select that as my encounter frequency. And then we can again use the animate command and just get an idea of how the vessel responds in a completely regular sea state. So this is waves of a constant frequency at around about the maximum response of the vessel. So that's a good way to just check a bit of a reality check on the actual response of our vessel relative to that wave frequency. And then the final calculation is a calculation in irregular waves. So what happens there is we take a whole lot of the different frequencies of the wave components, we create a random combination of them using the same proportions that are found in the wave spectra. That generates a natural sea state, and then we animate that to see how the vessel might respond over time. So you'll see that as these waves are generated, they're changing all the time, so they are genuinely random. And then as different combinations of frequencies come through, you'll see the vessel response change. So it's a reasonable simulation of what the vessel might see in a sea state with the same combination of frequencies as what we've used in our calculations. So that summarizes some of the visualization techniques that we have. All of these can be recorded using normal screen recording software to create AVI files for inclusion in presentations or for presentation to your clients. That finishes our webinar videos on Seakeeper. Thank you for watching.